Then we'll come to the final part of these DC motor 3-part sort of tutorials. So in this one we are controlling the direction and the speed that our motors are moving, but we are using a very different system than what has been used in the last 2 videos. So in this one we are using a different component, the entire circuit is different, and it has a very long code. So the new part of the circuit is actually called a H bridge. So it's basically more of a H. There are multiple different ones. The one that we're using is the L293D. It is the default one that comes in the starter packs for Arduinos, so make sure that you do actually read on the top of these little H bridges, because if you have the wrong one it can cause an issue. These are the actual things that you need. You need a H bridge, DC motor, and a 9-volt battery with the breadboard attachment. That there is the actual L293D H bridge. So as you can see, it's more of a H. You need to make sure that you know where that little indent at the end is. If you don't, it won't work. So these are the little connectors that you need on the 9-volt battery. If you don't have one of these, it's recommended that you get one, because they are actually useful for these motors. If you don't have one, it can mean that this whole system will not work. I have tried it without, and it just does not work properly. None of the motors spin, nothing happens. So this is the actual thing for the L293D. The actual image will be put onto the entire, will be able to be printed off. So these are the ground pins, so this shows you everything. So you have the ground pins, you have the out pins, so these are the output pins, so these are what we connect our motors to. We have our input pins as well, so these are in 1 all the way to in 4. The VSS is the power pins, and ENA and ENB are basically the controls for each side. So these run in correlation with that little indent. If you need this, you can print it out from the link in the description below, or you can just go to the website in this bottom corner of this image, lastminuteengineers.com, and the actual thing is on there, able to print it out with a better description about what each pin does. So these bridges can drive anything, so they can mostly drive motors, but they can be used for other things. There are 4 solenoids, which is our output pins. They have a very high supply range, as you can see. It goes from 4.5 volt to 36 volts, which is a very large supply. And the diodes and transistors and everything that we use are actually built into this bridge, so we don't actually need to worry about them for this. So this actually prevents damage to the motor while keeping it all very compact. It uses, this system that we're using today uses quite a decent amount of this, and it does look like quite a mess, but it's actually quite useful because it can control the speed and the actual direction. So let's go on to the actual coding part. So the new things that are being added to the code for this episode is just 2 functions. We are using extra voids, so instead of just using void setup and void loop, we are using 2 extra ones. We're using a switch speed, switch direction void, and a switch speed void, and we are using a for loop. For loops are a little bit more complicated than if and why, if while else loops kind of things, because they actually require a little bit more to set up, but after that it's quite easy. So let's start with a blank slate. We have our Arduino Uno there, because that is what Arduino we are using, and we need our little breadboard. So there's the breadboard, and that's it. So that is the beginning of everything. There we go. Right, so what we do need is we need a motor, as per usual. We need 2 of these, so we put one up there, and I'm going to put one down here, and I'm going to switch it, just like that. So there we go. And we're going to need a 9-volt battery, so let's just, there it is. We're going to rotate this as well, so I'm going to rotate that, and I'm going to put it there, just so that it keeps it a little bit more out of the way. There we go. And we're going to need a bridge. So how do I find this? Bridge. That's not how you spell bridge. There we go, bridge. There it is. So as you can see, that says L293D, and we want to put it across this little gap in the center, just because that's where it actually fits. It fits perfectly across there, and you don't need to worry about pins and everything like that. So we're going to start off by doing a simple thing. We're going to connect the ground pins on this. So as you can see, there's our little indent. Remember where that is? That is on the side closest to my breadboard for this diagram. So it goes from, so we count, some of them have a little dot there, some of them, my one does, it might not always. So we have the enable, the input, the output, the grounds. So they are what we need to focus on first. So we're going to connect our ground there, and then on the other side, not there, there, we are going to connect that to the other ground. Now, you do not connect both the grounds to negative. You do not need to do that. You can connect either one. It doesn't matter which ground you connect. You can connect that one to there. It really doesn't matter, but I'd recommend not connecting both grounds. It just doesn't do anything, and it just wastes it in case you need it for something else. So just do that. That's all you need, and that works. So now we're going to use yellow, and we're going to connect these there. It doesn't matter about the wire colour. They don't do anything different, but what I'm doing is, because I'm using yellow due to them both going to be used as yellow, so both of these are going to be yellow because it doesn't matter which pin they go into. It really doesn't. One thing that I would recommend, however, is with the other one, you connect the power to the exact opposite pin of the power for the other one. So there, I'd suggest that you do something like that. Just because that way they will both spin in the same direction. They won't spin differently or anything like that. So let's connect our ground here. So this is our motor's ground, so they are connected there. And that is that connected. So they're yellow because they don't need anything done to them. Again, just so you know, this is being recorded post-record due to microphone not being picked up. So we're now going to change our wire to green, and we're going to go from our input 4. So I'm going to go right at the end here, just so that it actually just makes it look a little bit different. So I want to connect this into 5 or 4. I think it's 4. Yeah, 4. No, was it? Yes, 4. I wanted to connect it into 4. Because 4 is not a pulse width modulation one, so you don't want to connect these to... These don't matter if they are actually pulse width modulation. However, this one of them does, so this one is being connected to 5, but it doesn't matter which one it's connected to. Although I would recommend keeping 3 and 9 available, because they are 2 that are going to be used for our pulse width modulation, which is going to be used to change our speed. So we're now doing the other 2 inputs on the other side, and these are going into 7 and 8. So 1 into 7, straighten that out a little bit, and then we're going to grab this one and we're going to put this into 8. That is the 4 inputs that have been actually connected. So all the 4 inputs that we needed have been connected. It's literally all we need. I'm trying to make this as spread out as possible with these wires, but it is going to start to look more and more messy, so if at any point you need to pause it, do so. We're now going to grab purple. Again, wire colour doesn't matter. I'm using it because I'm using an online version, and it actually does help to show which one it is. And I'm going to connect this purple into, I believe it's A. Yeah, I'm going to connect this to A. So this is the enable pin A, so it's just on this side. It doesn't matter which one it is. It could be either of them. Whichever one you decide for it to be, that is the one that is. So I could put it on the other side and said that that was A. It really doesn't matter which side has which one on. It will work the same, but make sure that you do have 4 and 5 and 7 and 8 connected on the same side, so that you know that they are both the same. I'm not going to grab orange for this one because it's a different colour. And we're going to connect our other pulse width modulation one, PWM, and that is going to go along, all the way along to our another enable pin, which is actually on the opposite side. So this goes right there. That is our other enable pin. Okay, so the enable pins are on opposite sides. That is shown in the diagram that we had before. So I'm just going to move these up because I want them to be slightly separate, just because it looks nice if they are. Yeah, there we go. And there we go. Right. So that just basically puts them a little bit further away than the others, just makes it look nicer. So we have our enable, all of that. It might not be on the other side. Make sure you refer to the actual sheet of paper. I'm actually just going to check right now, see whether or not it was. And yes, it was actually on the other side, so that is correct. The enable pin is on the other side, so it is correct there. So don't worry about that. We're now going to connect to both of the ground cables after connecting our ground to negative. So but once both of those are connected, that is the ground, and now we need to connect our power. This is quite a simple one. This goes all the way up. Now making it look like the London Underground, which I think is just really funny. And this is going to connect into there, power 1 there. That is our power connected. But now we need to add in our 9-volt battery. So this is what is also powering pretty much everything that we have. So this is powered into power 2. So let's just plug that in there. Straighten that out a little bit. And then we need our ground cable for the 9-volt battery to be plugged into ground. I'm actually going to straighten this out instead of keeping it looking like that, just because it looks a little bit nicer like that. So that is actually the circuit that is done. So if you need to have a good look at this and copy it, just pause it here and just do that. This is the actual, that was the circuit diagram, but because I have this, it's going to do that. So I'm just going to delete all these. Delete, 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 delete. Oh no, that wasn't delete. Delete, 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 and delete. So that means that when I actually open up this is the actual circuit diagram. So these show all of the actual way that everything looks. So that is our H bridge, that is our Uno, those are our motors, and that's our battery. So this is the circuit diagram. This is what is actually pretty much needed. So make sure that if you ever ask questions about anything, you have the circuit diagram like this on hand, because people prefer to look at this than the actual animated version. So some people find this easier to look at, but you can't exactly create it using the schematic view. However, you can using this. So now we're going to go on to the code. So this is where the long part begins. So we always start off by doing the first things, which is our integers. So we have the integer of n or a, which is this side, enable 1 and 2. So they are our enables, so that is NA. And that is plugged into, so we're going to change the name of these actually, because that is a terrible name for these. So we're going to call this A, and we're going to call this B. Right, so now we have motor A and B, and A is on the side of enable 1 and 2, so that means that A is equal to 9, because that's where that one is plugged into. We then have the in one, so this is our input 1 and input 2. That I like to do it like this, just because it means that I can actually do it at a quicker rate, but it's not actually a good idea to do it like that, because as you saw, you can create issues in your code by doing that. So just do that, do it the normal way. If you want to copy it and paste it, you can, but not recommended. So now I am actually going to just say what this is. So this is A, so this is the connections for A, so make sure that you always remember that that is what A is. So we're then going to do the same thing for B. So this is for pin 3. So this is the motor B connection. So this is the pulse width modulation. So they always have their little curly things there, little 4. They are what define it as pulse width modulation. So we now want to do in 3, and that is, I want to say 5. Yeah, there we go, 5. And then in 4, which is quite nice. This one is actually 4. So that is actually 4, which is great. So this is our motor B. So these are our connections for them. Remember, if you're doing these little additions, make sure you always do the slashes before, because otherwise it will actually try to read it as code, and it's not, and it will just produce a bunch of errors. So now we want to start on our void setup, which is actually a bit longer than the void loop this time, which is funny. So we want to do void setup, bracket, bracket, curly brackets. So in this void setup, we want to do the pin modes for all of these little integers that we've got here. So NA, N, which is output, NB, in1, in2, in3, and in4. They are all output. So what I'm doing here is I'm copying it and I'm going to paste it below, because that way it actually fits. So we need 6 of these, so 3, 4, 5, and 6. Because of how I actually copied it, they have all that, so we just need to delete those. There we go. And all that we need to do is we just need to change the actual integers that are put after the pin mode. So these need to change to B, in 1, and in 2, in 3, and in 4. So you always need to make sure that pin mode has a capital M. Output is always capitalized, same with input if you have something that's an input. So these are basically, so that basically tells you what they tells the actual code what they are. So it now knows that these are all output pins, so it will not try to read them as input, which is actually a necessity for pretty much every bit of code that you do with Arduino. You always pretty much need to make sure that you define them whether or not they are an output or an input. Now we are actually doing something a little bit different. We are actually digital writing part of the actual motors, so we're writing them to make them actually all off right now, because we don't want them to actually be on when we start the code. So we want digital write in 1 low, in 2 low, in 3, and in 4 low. We want all of those to be low, because that means that they have no power going through to them, meaning that they cannot spin. You can do the same thing by turning them on to high, but that might actually break your motor, so I wouldn't recommend doing that. Always keep them as low if you're turning them off, because it actually is guaranteed to work, because you're not actually putting any power, any voltage into the actual motor, which is actually very important. Having a cough. Oh dear. Okay, so now we're doing our void loop. This is actually the shortest void that we've got in this one. So it's literally, we are using the point of the next voids, which is going to be direction control. So this, you need to make sure that whatever you call these are the exact same as whatever you call the voids at a later date. So void control, void direction, so it's direction control here, but you could call it, say, DC, and this one SC, so speed control. If you want to make them shorter, you could do like that. You could call them anything, but make sure that you know what it is that they are. We are delaying these for 1 second each time, so that they actually have time to change over, but not such a length of time that they just cause an issue. So now we want to make sure that we close this loop, like that. Maybe. There we go. I've added a few little areas there, so I have a little extra. So void direction control, so this needs to make sure that it is the exact same as it is in the void loop. If it is not the exact same, it will not work. If it's not the same as that, it will just not work. So we then want to do the same as we did for the void loop. We want to do our 2 brackets along with the curly bracket at the end. And here is where it starts to elongate the code quite a bit. So, here we want to do a... What is it that we want to do? What did we want to do again? Ah yes, we want to do analog write part of this to be high. So NA we want to be 255. So that is actually turning the speed of these to the maximum, so the speed is 255, meaning that it's at the max speed that it can actually reach when it begins. So it will always be this speed regardless of what it is in the code, unless we actually change that. So we now have the NA and NB, which is our two motors, both of them, A and B, both being 255 speed, which is the highest it can go, about 1000 or 1900 actually RPM. We then want to actually start digital writing it, so we want to do in 1 high, but then we want to do the same thing of digital write, so digital write in 2, but we want this one to be low, because we do not want it to spin the other way as well as it's trying to spin the first way. So it's high and low so that it spins one way. So it's spinning currently, I think, clockwise, or depending on where you plugged it in, it could be anti-clockwise. I'm going to do the same thing for 3 and 4, so we want this one to be high, because it's actually the other motor, and we want in 4 to be low. So in 4, low. They are what we want it to be, because that works. Okay, so with this, make sure that you don't, so we want to put a delay here of 2 seconds, which is 2000 milliseconds, which is what the actual code works in. It works in milliseconds. 1000 milliseconds is 1 second, so 2000 milliseconds is 2 seconds. So what we now want to do is, so I'm adding notes here, so this just helps me to know what it is. So this is setting the motors to max speed, and this is just turning the motors on to one direction. Oh, forgot the slash there. So now if I hadn't got the slash there, that would have thought it was part of the code, tried to read it, and come up with a very confusing error. So now we want to copy this, we want to copy it there, so we actually get the right spaces, and we want to paste it. What we want to do now is we want to set this to low, that one to high, this to low, and this to high. So this is making them spin the other direction. So let's change this and make it so that it's spin the other direction. So switch the direction that it spins. Yep. Now, so that is the opposite to the other one, which is actually quite easy to see. Again, we have a delay of 2 seconds. And now we're going to do the final bit of this void, which is turning both of the motors off. So we want to digital write in 1 to low. We want to do that again, but with 2. So digital write in 2 as low. And then the same thing for 3. So write in 3 low. And digital write in 4 low. So this has set both of the motors to low, making no power go through them, turning them off, and we have to make sure that we close it at the end. That is now closed, and it's turned off the motor, which means that that is the end of that loop. It doesn't actually loop constantly because it's just its own void. So it is literally in the void, which is why we had to put it into the void loop so that it actually used it. So we now want to use our speed control. There we go. Again, you can call this SC or whatever, so long as it matches this part of the void loop. So for this one, we want to do a little bit different. So this is going to make use. So we want to digital write first of all. Before we go on to that, I want to digital write in 1 as low. Digital write in 2 as high. So this is the same as the switch directions one at the top there. So this is just making go in one direction. It doesn't matter which direction it moves in, so long as it actually moves in a direction at the beginning of this thing. If it doesn't, then it won't work properly. But if it does, then well done, you've actually got it moving. So that is the same, so that is just making them spin. It's used there. It's a different direction, but it's still spinning, so it still works. Okay, so now we are actually moving on to the extra new thing that we have here. So this is the new loop that we are going to use, which is our for loop. So we're going to actually add a little thing here that says that we're turning them on, because that's what it is, it's turning the motors on. So this is motor A and B, or we're referring to them as A and B. They are 1 and 2 as well. It doesn't matter which way you call them, 1, 2, A, B, Jeff, Bob. It doesn't matter. It's just a little bit thing that makes it easier by calling them A and B. So now we want to do a different thing. We want to use the for loop. So this is where we brought them in. So for integer I, so that equals 0, colon. So I is less than what was it, 255. So if I is less than 255, well, that's 256. That might be my issue. I plus plus. So if it's less than 256 here, but I've set that to 50 because I want I to equal 50, not 0, because if it's less than 50 it will just make a really high pitched beeping noise, and we do not want that. So what that does is that is defining integer I as 50, and then if the I is less than 256 it will add to I, so it will increase the variable that we have for I until we reach 256. So it will start off at 50 and it will go up until we reach 256 constantly. When we reach 256 it will stop, but it will stop the code that we have to put in afterwards. If there's no code it won't do anything. So that's what the I++ does. Now we will be using another I later, so we're using minus I, so that will decrease I by 1 each time until it reaches a certain point, and then it will stop. But that's how it will work. So we're going to analog write, we're going to analog write NA as I, and we're going to analog write NB as I. So these are our digital pulse width modulation pins. So these are NA and NB. We then want a delay of 20 milliseconds, not 2 seconds. You want 20 milliseconds. And then we're going to put in another for loop. So we're going to do for integer I equals 255 and then if I is greater than or equal to 0, then it will minus I. So that is where that for loop ends. Again, that should be 50, and the 256 should be 255. It's just a little bit of things wrong there. So we now want to do another analog write. We want to do NA as I again, and we want to do analog write NB as I. We do not want that capitalized actually. Hang on, there we go. Right, fix that. So analog write I, there we go. And then we want another delay of about 20 milliseconds. 20, there we go. 20 milliseconds. Close that for loop and close. Yeah. So we will then actually want to copy this before we close actually the speed control. We want to copy that and we want to paste it there. So that will turn off the motors. And there we go. Right, so we will just add a little thing here. So from 0 to 255. And then here from 255 all the way to 0. Right, so let's close that. Make sure that we close it. There we go. That's closed now. That wasn't closed before. That needs to make sure it was closed. There we go. Right, so let's. Yeah, so that's actually, so it's pause it at each point. We have the direction control. There was the speed control all shown there before. and then we've got void loop here along with void setup and integer. Pause them where you need them. If you need to copy down any of the code, it doesn't change anything. And right, so let's just try and minimize this. Can I move this aside? No. Okay, well, alright, so let's hide the code and let us start the simulation. Oh, there's an error. Right, so what I did here was I actually wrote analog write wrong. I'd put an F instead of a G, so there we go, just fixed that. There we go. Run the code. Why is that opened? And it's not spinning. Okay, so here's actually a little bit of a fun fact for you. It didn't actually work on Tinkercad for some reason. There might have been just a few little mistakes in the code. I don't know why it wasn't working. I tried to work it out, but I have actually got here. This is the actual code, so this is the one that works. I have this actually sitting on a Arduino board next to me. This is one that completely works, so I'm just going to copy and paste this into there. It is exactly the same code. I will actually put this in the description. Missed a bit. Oops. So I'll actually put this in the description so that it can actually be read, because for some reason it's not working online, but it does work in real life. So yeah, that didn't work. Okay, let's try again. So as you can see, there's a lot more indents because that's how it works on the system. However, when we start again, why is there a resistor? However, when we start it again, it's still not working. So I don't know what's going on here. Something probably wrong with Tinkercad. Some things don't work exactly the same as it should. Could be the fact that that's selected, but I'm not entirely sure. It's the exact same code as the one before. Nothing actually changed. So the code does work the same. Just make sure that you don't put 256, even though I did. So just make sure that it's always the same. Make sure it's the exact same as what I did there, because that way it does work. Actually, you do want it to be 256 because it's not equal to. Unless you do equal to, you want it to be 256. That is the code. It'll be in the description along with a link to the page that the L29, an image for the L29. So just make sure that if you do copy the code from the description, what I'd recommend is actually writing it out, because it means that you actually learn what you are actually writing instead. So write it out, following along with it. If there's stuff that you actually fully understand what's going on, then you can copy it. But if you don't, I'd recommend writing it out so you actually know roughly what is happening. Refer back to the part before I pasted it, because there are all those headings there, and that tell you what is happening for each part. So that is actually all I've got for this one. This is actually one of the longer episodes because it took a long time to set up and it was a complete new system. It is a very useful system because it can actually be used for controlling the speed and the direction of this motor. Make sure that you have got that one in. If you don't, it could start to overheat and you don't want it to. It's actually very useful, so try not to break it if you have one. But anyway, that is everything for today. Thank you so much for watching. Goodbye.